My name's M.Simon. I'm a professional geotechnical engineer. My colleague John Ding invented this device several years ago to measure the thickness of sediment that might remain at the bottom of a drilled shaft after excavation and cleaning, but prior to concrete. The principle of operation is pretty simple. The unit is lowered down to the bottom of the shaft. These three legs will penetrate into the sediment while this light steel plate will remain on top of the sediment as the legs penetrate. The thickness of the sediment is represented by the distance between the bottom of the legs and the bottom of the plate, and the measurement of the thickness is determined by this linear variable displacement transformer, or LVDT, that puts out an electronic signal to the readout box, and the readout box shows the relative displacement in millimeters. Assembly of the system is straightforward. There are two ends to the cable. One has a larger waterproof connector with steel hangers attached, and the end for the readout box is smaller and is not waterproof. To connect to the cable, there is a key that only allows the plug to be inserted in one orientation, and then this lock nut is tightened firmly to make a watertight connection. We warn you not to over tighten that nut, as it may damage the threads or destroy the watertight connection. Then it's necessary to connect these green cables to the three lifting eyes that provide the physical connection between the measuring unit and the surface. The readout box is also straightforward to connect. It has a key which determines its orientation, and then the nut on the outside keeps it in place. Finally, it's necessary to connect the unit to a power source, and we're using either 110 or 220 volt electrical source, and that plugs in very simply. The next step is to install the measuring unit into the drilled shaft. We have our model drilled shaft over here, and I'm going to lift it up. This unit weighs about 15 pounds. It can be handled by a single person. I'm going to drop it slowly through the water, and I can feel it hit the sediment, and it's penetrating the sediment, but the plate has lifted up, and the plate displacement is about 54 millimeters, about 2 inches, and that shows about correct from what I can see on the side of this plastic cylinder. We recommend that you perform about 3 to 4 measurements on each shaft, depending on the diameter. Perhaps 1 in the middle and 3 or 4 at the perimeter. To do that, it's only necessary to lift the unit several inches off the bottom, slide it over to a new location, and lower it down onto the bottom, and observe and record the new sediment thickness. Once all readings on the shaft have been completed, the measuring unit should be removed from the shaft and disconnected. The unit should then be hosed down to remove any clay, sand, and slurry, provide a relatively clean field unit, and If it's necessary to transport this either to another shaft location or back to the field, back to the office, then we recommend it be replaced in the Pelican case for further movement. Once a day's operation is complete, we recommend that you return the measuring unit and the other elements to the field and clean them thoroughly, drying off with hand towels, and finally letting them air dry so that there's absolutely no moisture left that might tend to develop mold in the case. Finally return it to the dry case. If you have any questions on this material or any other elements related to the sediment thickness measuring system, please contact John Ding at dmy-inc.com. His contact email and telephone are available there.